Uh, Dear student, I hope you have read the question. This question will require a little bit of mathematical knowledge, so I'll explain what it is. It says a block of mass m is placed on a surface with a vertical cross sectional given by y is equal to x cubed by 6. Y is equal to x cubed by 6 is the cross sectional of the surface. So what does that mean? If I take this as a coordinate system, x cube is a kind of very steep graph. It's going to be like this, let's say, and somewhere here a block is placed. Okay, let's say a block is placed like this. Now the maximum height above the ground at which the block can be placed without slipping. So this should not slip down. So what is the maximum height where I can place this? Now, and the coefficient of friction is given, I suppose, is 0.5. Right? Mu is given to be 0.5. Okay. Now, what is going to happen is if I place a block here like this, its mg is going to act downward. This is mg. I can resolve mg into two components, one like this and another along the path, right? So if I consider this angle to be theta, this will be mg cos theta and this will be mg sin theta, right? Now at this point this surface is going to exert an upward force which is called normal reaction in this particular direction. Now mg cos theta is going to pull the block in the downward direction. Now to stop that, there is going to be a upward force which is a frictional force. So I am going to have Fr here, frictional force. But if you see, as I go up and up, it is going to be more and more steep. So mg sin theta is going to increase, and at some location, as you know, the frictional force has a limiting value. So if this mg sin theta is equal to frictional force, which frictional force reaches a limiting value, the block cannot be placed any further on that, right? So first thing what we need to say, first we'll write a couple of equations. So in this direction, since the balancing is there, n will be equal to mg cos theta, right? And in this direction, Fr is equal to mg sin theta, right? So this is for equilibrium of block. Now for limiting case, Fr should be equal to mu times normal reaction, right? We have seen that in theory. So that is equal to mu times normal reaction is mg cos theta. So Fr I can compare this. So mg sin theta is equal to mu times mg cos theta. Mg sin theta is equal to mu times mg cos theta. So mg goes off and tan theta is equal to mu, right? So far so good. So that is the maximum height, that's a maximum angle where we can reach, not beyond that. Now at this point, if I draw a tangent, understand this very carefully, if I draw a tangent, even this angle is going to be theta, right? Why? Because angle between this and this line, we have a theorem, angle between two lines is equal to angle between their perpendiculars. So to this line this is perpendicular, and to this line this is perpendicular. So angle between these two should be equal to angle between these two. So this is theta, right? Now this is the angle with x-axis, right? So, and now I have an equation of this curve. So I can get this tan theta by a derivative concept. So tan theta from derivative concept is nothing but dy by dx. So that's a type derivative of y with respect to x. So derivative of 3x square is, derivative of x cube is 2x square, 3x square by 6. So that is x square by 2. Right? So now I got tan theta as x square by 2 and tan theta is also equal to mu. So x square by 2 I can equate to mu. So mu is given to be 0.5. So 0.5. So x square becomes 1. So x becomes 1. Right? So at x is equal to 1, that's the maximum. X equal to 1, this is going to go at the maximum height. But then what would be the height? I have to put this x into this equation so I can get the y of this. So if I put x is equal to 1 into this, I am going to get y is equal to 1 by 6. So that is the answer. So maximum height from the ground, I assume x-axis to be ground. So from the ground up, 1 by 6 meter is the maximum I can place that block without it slipping on this surface. Clear on that? Slightly mathematically involved, but very interesting question.